Welcome to Maths Guru Educational Services. If you are studying with us for the first time on Maths Guru channel, or you have not subscribed to our channel, kindly do so you'll be informed anytime we upload a new video on this platform. You are to also share a video and comment as well to help us serve you better. As stated earlier, this channel is dedicated to those offering educational administration and planning at the National Open University of Nigeria. Please, if you know of any platform that these people are, you can forward the video to them so as to ease the problems or the tasks that are involved in this course material. This unit, we are going to discuss measures of variations or measures of dispersion. All right, we have the units displayed here. The measures of variation or dispersion or spread of data are measures which show the variation or spread or dispersion of values or scores in a given distribution. So the terms that are associated with these scores are underlined here. The first, we have the dispersion, the variability, the spread. You can also talk of scatter. When you are asked to measure how the data are scattered or the data are spread apart, then we are talking of the measures of variations or measures of variability. All right, then the second paragraph here, we have the homogeneity or heterogeneity of the scores can be established with these measures. So this is actually talking about the importance of the measures of variations or dispersion. So we can establish the homogeneity or the heterogeneity of the scores of any given distribution given to us. And what do we mean by homogeneity or heterogeneity? In data analysis, if the scores or the variables considered are of one type, then we say it is homogeneous. So we consider such scores as homogeneous because they are of the same types. All items in this kind of distribution have the same characteristics. That is what we mean by homogeneity. But when we talk of heterogeneity, it is the opposite of homogeneity. It means the scores or the variables considered in the distribution are of different type. So all items in the distribution have different characteristics. Take note of this. That is just the difference between homogeneity and heterogeneity. All right, the measures of dispersion or variation or the measures of spread includes the range. This we have discussed before. The quartile, the decile, the percentile, mean deviation, variance, and standard deviation. These are the measures of variations. In our previous classes, we've already talked about the mean, the median, and the mode. If you have not watched that video on how to calculate the mean, you are to do so because it will be of great importance in this course. Please kindly do that. Go back, search for the video on the mean, median, mode of a distribution and get yourself acquainted with the different methods of calculating the mean. It will help us in this discourse. All right, our focus in this discourse is, first of all, to be able to define the mean deviation, variance, and standard deviation. And secondly, to calculate the mean deviation, variance, and standard deviation. We have other measures of spread, but we are not concerned with that today, not concerned about that. So we have this range, quartile, and the decile, the percentile, but our major focus is on the mean deviation, the variance, and the standard deviation. But for us to do this, we have to know how to calculate the mean of any distribution. If you do not know how to calculate the mean of any distribution, please do so before you continue to watch this video. All right, please subscribe. We are going to do this in line with the past questions given to us as usual. That is what we've been doing. So we have this fourth question taken from the past question of 2019, that is in April, and this is also taken from 2018 past question. In this first part of the question, we are required to calculate the mean, the standard deviation. We want to calculate the mean and the standard deviation, but we are going to in a way generalize this question to calculate the mean, the mean deviation, and standard deviation. Okay, variance first, and standard deviation. All right, there is a relationship between variance and standard deviation that we're going to see as we move on. All right, we are going to use each of these questions to work with our focus today. All right, the mean deviation. The mean deviation simply means the mean of the absolute deviations of the mean from the scores of a distribution. This seems confusing if you do not take your time to understand the grammar here. It is the mean of the absolute deviations of the mean from the scores of a distribution. That is, it is the average of the absolute deviations of the mean from the scores of a distribution. This is quite simple. But as stated earlier, we have to first of all know the mean of this distribution. And to determine the mean of this distribution, let's go on. Solution. The mean is calculated by summing all the data of this distribution together and divided by the number of times the number of data we have in this distribution. And by that we mean we add 40 to 50 to 80 to 60 to 30 to 25 to 90. We add everything to 75 to 40 and then 60, and divided by the number of data we have is stated here already, 10. When we add all this together, we're going to have 550, and we divide it by n, which is 10. So we are going to have 55 as the mean of this distribution. All right, before we proceed, there is this concept I want to draw our attention to again: absolute deviation. When we talk of the absolute deviation, we are going to disregard either the positive or the negative value of any score. That is the negative sign, of any score. If the deviation is going to be -6, for instance, we are going to consider the absolute value, which is going to be just 6. That is what we mean by absolute. We are going to disregard the negative sign. Take note of that as well. So, having known the mean, the next target is to know the deviation of the mean from the scores of this distribution. The scores are 40, we have 50, have 80, we have 60, 30, 25, 90, 75, 40, and 60. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. All right. For each of these scores, we are going to calculate the deviation of the mean from them. Okay. By that, we mean the difference between the mean and the score. The difference between the mean and the score. So we are going to subtract the mean from each of these. Minus 55. Minus 55. Minus 55. Minus 55. All right. So we have to do that to all the data or the scores we have in the distribution. 40 minus 55 will give us negative 15. 50 minus 55 will give us negative 5. 80 minus 55 will be equal to 25, right? 60 minus 55 will be equal to 5. 30 minus 55 will be equal to 25, negative 25. Then 25 minus 55 is going to give us negative 30. 90 minus 55 is going to be 35. 75 minus 55 is 20. 40 minus 55 is still 15. And 60 minus 55 is going to give us 5. All right. Having got this, we refer to all these differences as the deviation of the mean from the score. The deviation of the mean from the scores. Take note of this. You will notice that if you add all these numbers we have, you are going to have 0. So we are not going to consider these the negative sign that are attached to some of the deviations we have here. So we are only going to consider the absolute deviation, and by absolute deviation, as I said earlier, we disregard the negative sign. So we are going to have here as 15, here will be considered as 5, 25, 5, 25, 30, 35, 20, 15, and 5. All right, the mean deviation is given by the sum of the absolute deviations, that is x minus x bar of the mean from the scores of the distribution over the number of data in the distribution, that is n now. So using this formula here, we're going to have mean deviation equal to summation x minus x bar over n. And we have to sum this absolute deviation now. Absolute deviation, sum everything together. 15 plus 5 plus 25 plus 5 plus 25 plus 30 plus 35 plus 20 plus 15 plus 5. And quickly do that. We're going to have 180 over n is 10. And 180 divided by 10, we're going to have 18 as the mean deviation. All right, we have here the variance. We have already determined the mean of this distribution, and the mean is simply 55. That is taken. Since we're working with the same data, we have the mean retained here. And the variance is the arithmetic mean of the squares of the deviation of the mean from the scores of a distribution. This time around, we are not going to talk about only the deviation of the mean from the scores. Rather, we are going to square this deviation of the mean from the score. And okay, let's quickly have what we did there copied. All right, we have all this data given below here as the deviation of the mean from the scores. So in variance, we are going to talk about the square of this deviation. The square of this deviation. So we have to square all these deviations. We have negative 15 square. We do that, 15 square, and that will give 225. We have a negative 5 square, which is going to be 25. Negative 25, just 25 square, which will be 625. 5 square again, we have 25. 25 square, we're going to have 625. Then we have 30 square. 30 square will give us 900. Yes. 35 square should be 1225. 1225. 20 square will be 400. 15 square, we've done that before, 225. And 5 square is 25. All right. So this is referred to as x minus x bar square. So it is the square of the deviation of the mean from the scores of a distribution. But we are concerned about the mean of the square of these deviations from the mean. Of the mean from the main score. So we're going to sum all this together and divide it by the number of scores we have in this distribution. Quite simple. So let's add everything. That is summation x minus x bar square will be equal to, all right, we add 225 plus 25 plus 625 plus 25 plus 625 plus 900 plus 1225 plus 400 plus 225 plus 25, and we're going to have 4,300. 4,300. All right. Recall that the variance we use the Greek letter sigma equal to sigma. This is also a capital letter of this, x minus x bar square over n, and we have 4,300 over 10, and 4,300 over 10 is 430. So this is the variance of this distribution given above. We recall that variance, like other measures of dispersion, is used by both analyst and trader to determine volatility. By volatility, we talk of the measures of risk. Volatility is a statistical measure of the dispersion of return from a given security or market index. So when we talk of volatility, in this case we say the higher the volatility, the riskier the security, yes. For instance, when the stock market rises and falls more than 1% over a sustained period of time, it is called a volatile market. So an asset volatility is a key factor when pricing option contracts, especially for those who want to go into project management. You need to get yourself acquainted with some of these principles. Now we have the standard deviation. The standard deviation is quite simple. The standard deviation is the square root of variance. For this distribution, we recall that the variance we got is back, right? The variance we got is 430. So the standard deviation is simply equal to the square root of variance. So we have the square root of 430, and our answer will be 20.74 approximately. All right. So the relationship between variance and standard deviation is that variance is the square of standard deviation, and standard deviation is the square root of variance. Take note of this. All right, we have the other question that involve the table. So we have the question here, and we are required to calculate the variance and standard deviation, but we need the mean deviation to calculate the variance and standard deviation of the scores. Remember, to get the mean deviation, you also need to get the mean itself. So we are going to do all this together here. Find the mean of this distribution. We are going to also calculate the mean deviation, then we calculate the variance and standard deviation of the score. So we start. We're going to find the mean first. And how do we do that? Recall that mean is given as, that is, the mean for this kind of distribution is the summation of fx over summation f. Summation fx over summation f. And summation fx simply means we add the product of the score and its frequency together. Then summation f means we add all the frequencies together. Let's quickly find our fx. We are going to extend this table. All right, we have fx here. Fx means we multiply this and this. 9 times 1, 9. 10 times 2, 20. 12 times 3, 36. 13 times 5, 65. 14 times 9, 126. 15 times 15, we did that before, 225. 16 times 10, we have 160. 17 times 5 is going to be 85. 18 times 3 is 54. And 19 times 2 is 38. So we have our summation fx to be equal to, we're going to add all these values together. 9 plus 20 plus 36 plus 65 plus 126 plus 225 plus 160 plus 85 plus 54 plus 39. This will be equal to 819. And summation f will be equal to 1 plus 2, that is 3 plus 3, 6 plus 5, 11 plus 9, 20 plus 15, 25 plus 10, 35, 50 plus 3, 53 plus 2, 55. Yeah, 55. So the mean will now be equal to, our summation fx is 819 over summation f is 55. And when we divide this 819 divided by 55, we're going to have approximately 14.9. 14.9. Right? Remember, our mean is equal to 14.9. So we can attempt the question now. The mean deviation, that is what we want to calculate first. And remember what we did for this kind of data already given on a table. We need to find the deviation of the mean from each of these scores given. The scores given here. We just have our table extended here. So we're going to have x minus x bar, which is the deviation of the mean from the score here, x. We're going to leave out the frequency for now. So this is what we're going to do. 9 minus the mean, which you've got here, 14.9. And this will be equal to negative 5.9. Negative 5.9. Okay, for this 10 minus 14.9, we're going to have negative 4.9. 12 minus 14.9, we're going to have negative 3.9, right? Yeah. So we're going to have negative 2.9. 13 minus 14.9, we're going to have negative 1.9. Yes. 14 minus 14.9, we're going to have negative 0.9. And then we have 15 minus 14.9, which will be 0.1. 16 minus 14.9, we're going to have 1.1. 17 minus 14.9, we're going to have 2.1. 18 minus 14.9, we're going to have 3.1. 19 minus 14.9, we're going to have 4.1. All right, since we are focused on calculating the mean deviation, we want to have the positive value. You can multiply before you get the positive value anyway, but let's just have the positive value first. So we're going to calculate the absolute deviation. The absolute deviation of this is simply 5.9 for this, 4.9 for this, 2.9, 1.9, 0.9, 0.1, 1.1, 2.1, 3.1, and 4.1. So we still need one column more. A row, sorry. We need a row more. This row, we are going to have F into S minus X bar, because the data we have here are recurrent. We have the values or the scores in this distribution appearing more than one time, like 10 appearing 2 times, 12 appearing 3 times, and so on. So what we're going to do now is to multiply the frequency by the deviation we have, the absolute deviation we have here. And that is going to be 1 times 5.9 is still 5.9. All right, 5.9. Let me use another ink, please. 5.9. Then we have 2 times 4.9. 2 times 4.9 we give 6.9. 3 times 2.9 we give 8.7. 5 times 1.9 we give 9.5. 9 times 0.9 we give 8.1. 15 times 0.1 we give 1.5. 10 times 1.1 we give 11. 5 times 2.1 we give 10.5. 3 times 3.1 we give 9.3. 9 times 4.1 we give 8.2. So the next attempt now is to sum the last row we have here, which is summation F of X minus X bar. All right. We already know our summation F to be equal to, is calculated here, summation F 55. Take note of that. Summation F is 55. So what we need now is summation F of X minus X bar, which is this row. Now we add everything together. When I added everything together, I got 79.6. You can try that out and see if your answer will be the same as we got here. So we can calculate the mean deviation using the formula. Mean deviation is equal to summation F into X minus X bar over summation F. This is because the data we have here are recurrent one, and as arranged in the table here is very obvious. So we're going to have summation F of X minus X bar is given here, which is 79.6. We have 79 5.6 over summation F is 55. So when we divide it by 55, we are going to have 1.44447, approximately 1.4 as the mean deviation. Now let's calculate the variance now. Okay, we have the variance. Remember, what we need to do here is to square the deviation. We have to square the deviation from the of the mean from the score. So we're going to copy the table we have earlier here. All right, so calculate the variance. We are going to square the deviation of the mean from the scores given above here. We have the scores here. So we have the deviation of the mean from the scores given here. So we need x minus x bar square. We square these deviations given, that is negative 5.9 square, 5.9, we square it, and we have 34.81. 34.81. We're going to square the rest. So we have negative 4.9 square to give 24.1. 2.9 square to give 80.41, negative 1.9 square to give 3.61, negative 0.9 to give 0.81, negative 0.1 square to give 0.01, 1.1 square 1.21, 2.1 square we give 4.141, then 3.1 we give, the square of 3.1 we give 9.61, the square of 4.1 we give 16.81. Now we're going to multiply the frequency with this, that is summation. We are going to have f of x minus x bar square, f of x minus x bar all squared. So we're going to multiply the frequency by what we have here in this row. So 1 times 34.81 will be 34.81. 2 times 24.1 will give 48.2. So let's do that for the rest. All right, so when we multiply the frequency by the square of the deviation of the mean from the score, as seen, you will have this row, that is this very one. So the next target is to sum the column we have here for f of x minus x bar square. And when we add all these together, we're going to have 446.33. And remember, summation f is equal to 55. It's given here. We use that here. So let's quickly have a formula for a variance of this kind of a distribution. The variance, sigma square is equal to summation f into x minus x bar square over summation f. And from here, we have our summation F into X minus X bar all squared as 446.33. We divide it by summation F, which is 55. So when we divide this by 55, we're going to have 8.115, approximately 8.1 as our variance. This is to 1 decimal place. Now, to calculate the standard deviation now is very simple. Remember, this variance is equal to 8.1 as reduced there to 1 decimal place. The standard deviation is equal to square root of variance. And we are going to have the square root of variance is, our variance is 8.1. So we're going to look for the square root of 8.1. The square root of 8.1 is 2.846, approximately 2.8. So the standard deviation is 2.8, the variance is 8.1, and mean deviation is approximately 1.4. By so doing, we have fully resolved the 2 questions that were given to us. Please don't forget to subscribe. All right, just to call your attention here before we move on, we have a question here which states, give 5 measures of dispersion. Give 5 measures of dispersion. I believe by now you should be able to list 5 measures of dispersion and define mean deviation, variance, and standard deviation. At least if you cannot recall any of these, you should be able to recall the mean deviation, standard deviation, and variance for today. Thanks for watching our video. Thanks for studying with us. Please don't forget to subscribe to our channel so you'll be informed anytime we upload any video. Please share with your fellow students. Share with them. We want to serve you better. Comment and suggest ways of improvement. Thanks.